This problem is a geometry from RMO 2019. It's a Regional Math Olympiad from India. And it basically says something like this. If you have a triangle, so let me draw a triangle here. I'll draw it as a scalene triangle, but at the end of the day, we need to prove that it's equilateral. So let's draw something like this. So we have a scalene triangle, and let me give a name to this triangle. Suppose A, B, and C. There is the centroid of the triangle is known as G. So let me write that here. So G is the centroid of the triangle. What is the centroid? The centroid is the intersection point of the medians. So what this means is, if you join the point A with the point G and produce it, suppose it meets at D, then D is the midpoint of BC. So BD is equal to DC. So that's the meaning of the word median. That's the meaning of the word median. It basically it is the intersection point of the lines joining the vertices with the midpoint. So let's draw this one as well. Let's call this one as F. So we have D, E, and F. Now it's not immediately clear why these three lines should be passing through the same point. I want to make a comment here that if you have in general three lines, they may not pass through the same point. In this case, however, all of them are actually passing through the point G. Now this is a non-trivial theorem. You need to prove this, that this actually happens in the special case when you are joining the vertices with the midpoints. So this is a very special scenario. Now what we want to do is we want to draw a circle. Let's draw it like this, the circumcircle of ABC, and we want to produce this line AD or the median AD to meet the circumcircle at A1. We want to produce BE to meet it at B1, and let's produce CF to meet it at C1. All right, now what? Now we'll be joining, let's use the scale one more time. We will be joining A1 and C1, A1 and B1, and let's join B1 and C1. So maybe I could have used a different color, but anyway. There is some additional information given to us. It's given that this angle here is equal to this one. So the green angle is equal to the green one. The red angle is equal to the red one. And let's use a different color. Let's say the blue angle is equal to the blue angle. So that's the information that is given to us. And what do we need to prove? So our goal is to show that ABC, the triangle ABC, and the triangle A1, B1, C1 are both equilateral. So in this particular video, we will be describing a hint so that you can try it on your own, and then the next one might have some more hints and maybe the entire solution. So what is the hint? So the hint is a lemma like this. So a lemma is like a short theorem that can be used to prove a bigger theorem. So what is the lemma? So the lemma is the following, that if you have a circle, let me draw a circle like this, nice and round, and suppose we have two chords of the circle, maybe AB and CD, So AB and CD are two chords, and the intersection point is M. So intersects at M. If M is the midpoint, of both AB and CD, then AB and CD are diameters and M is the center of the circle. M is the center. Now, so if we know that M is the midpoint of both AB and CD, both the chords, then we know a lot of information about these chords. That they are the diameters of this circle, and M is in fact the center of the circle. So how can you show this? Well, I'll let you prove this, but I'll give you a construction. Suppose this point is O. Suppose M is not the center. So suppose M is not the center. Then if you join OM, so suppose O is the center, so there will be a center of the circle, so maybe O is the center. Join OM. So what can you say about the relation of OM with AB and CD? So you can say two things, that OM is perpendicular to AB at M and OM is perpendicular to CD at M. Why can you say this? Well, if you join the center to the midpoint of a chord, you know M is the midpoint, right? That's given. M is given to be the midpoint. So if you know if you are joining the center to the midpoint of a chord, then it's automatically perpendicular to the chord. Now, can you prove that? That's a different theorem from geometry. So try to prove that and use this lemma to prove that in fact ABC and A1, B1, C1 are equilateral triangles. Give it a try, and in the next video we will talk how to use this lemma. We'll describe how to use this lemma to prove this beautiful problem.